So what is the purpose of this talk? So firstly, we want to simplify adopting Zephyr because West may seem confusing at the beginning. So we might not know why it exists and why do we even need this tool. So we just want to clarify these concepts. So we want also to clarify misconceptions about the West complexity. And also we want to provide a clear understanding how to use West from like fetching the dependencies to building, flashing, and doing the different commands. And there's also something personal here because when I first started with Zephyr, I didn't like West and I didn't understand, I didn't get the tool. So this is why I decided maybe there's something wrong either with me or with this tool. So I tried to learn more about this tool. I was first using Zephyr with CMake because everyone's just familiar with CMake, so why not just directly using it? And then I understood maybe this tool makes sense, and it's actually very powerful. And it is going also beyond the scope of Zephyr. It is very large and very big, very important tool. So we'll start by doing an overview about West, what are the features that we have, and then we're going to focus on their two main features that we have in West. So firstly, what problem is West solving? So Zephyr is made of several small projects. They are separate Git repositories. And Zephyr itself is just one of these Git repositories. And we also depend on other Git repositories. For example, if you want to get the HAL from the vendor, you need the NXP, HAL NXP. There's also a repository for ARM, which is for the KIMSys, maybe for the bootloader, maybe for other third-party libraries, and many other things. So why this is a problem? Because actually we have many repositories, so we just need to clone each repository and doing it manually. This doesn't seem like a good idea. So maybe, and each repo may have different version. We might also have dependencies between those repositories, and we have different requirements, and so on. And if you want to manage all of this manually, this is actually it will become a nightmare. So no one is going to do this. So why not just use existing tools for this? They existed for a long time, like submodules or repo. So firstly, if we want to use Git submodules, the idea, it has many advantages. So we can link it to other Git repository from the parent repo. We also have versions. We can keep track of what we need. But at the same time, it is easy to break if we do not work with it carefully. And there's no built-in support for like grouping and doing conditional inclusion and doing some advanced here dependencies between the different repositories. So this is why we also have Google Repo, which is also very powerful, and it's been used and embedded for a long time. It is also used by Android and very large project. It has a manifest and it works very well. But at the same time, it is very heavy and complex, and not easily extensible. We cannot do easily like custom commands. And it is poor fit for small embedded systems. And this is why, yeah. So there's also other problem that West is going to solve. Actually, West is going to provide we'll try here to provide a unified command interface for development. And without it, like developer might need to use different tools, different scripts, different environments. And actually, nowadays, if you want to use like something from a specific vendor, each vendor going to have his own tools, his own way for doing things. So in Zephyr, we want to standardize everything. So this is why we have this tool. So we try to unify everything. So in West, we're going to standardize commands across board, vendors, environments, setups. And we only have one way for managing the system. And this will give you and provide a consistent experience regardless of the platform that you're using. So either you are on NXP or Nordic, you are going to manage your system in a similar way. And by the way, in my opinion, so today is used only on Zephyr, but in my opinion, it's going to go beyond Zephyr and become like the standard way for managing embedded projects. And it's actually being used by some vendors beyond Zephyr for doing their own their own SDKs and their own project on bare metal without even using Zephyr. So here we have only one tool that's going to do the core actions. So firstly, if you want to build your project, you just do West build, and it will just simply build your project. So you would be thinking, well, if we do right-click build on an IDE, it will do the same thing. Well, this is true, but each vendor is going to have its own magic happening behind the scene. And in this case, we have West, just one tool for all the vendors. You don't need to change the environment. It is still the same setup. So same thing also for flashing and debugging, because flashing the system and debugging it, it might also be very platform dependent. And in this case, we also try to standardize it as much as possible. Of course, in addition to testing with Twister. So what is West solution? So West solution is try to be lightweight. We're going to try to solve Zephyr-specific challenges, but there are also challenges for like modern complex embedded system, because nowadays embedded systems are becoming much more complex, and in order to cope with these systems, we have a lot of challenges that West can fix them. And it is also extensible and easy to understand. So once we get it, so it will be easy to understand, and we start using it. And will also help us not only to do commands, but also to manage our repositories and everything just from one tool. So the question would be, what is West just in simple words? So West is actually a command line tool. So if we want just to do a definition for West in simple words, it is a command line tool that is designed for, firstly, managing the different repositories. So it is repo-like, but just more advanced. It provides like useful tools like building, debugging, flashing. So just basically going to run Python scripts for us. And also it will provide a consistent workspace. So it is uniform workspace format. So your code and dependencies, they're all going to work together seamlessly. So in simple words, it is a repo-like that's going to run Python scripts, and it has a uniform workspace format. So West is not just a project manager, it's just a meta tool. So what is a meta tool? So meta tool, it means that it's going to wrap together like different tools in one tool. So we're going to manage the project, as we mentioned, building, flashing, custom command, doing whatever we want in just one tool. And also, specifically for Zephyr, it is designed to work naturally in Zephyr. You don't need to do additional things. It will just work. You do West build, it will just understand everything about the build and just going to work. And it works very well, actually. So what are the key roles here in Zephyr? The first one is we have Git repository manager, and also the second thing is the command executor. So regarding the first part, this is where we're going to manage the code base. We have at this level the manifest parsing, and this is based on a file called west.yaml. And then we have a special layout for the workspace. This is where we're going to see on your local folder where you're going to find the Zephyr code, the source code of Zephyr in a folder, the different modules, the application, and other things. We can also sync projects. If you change a version, it's like doing repo update, so similar to Zephyr feature here for updating the repos. And we can also group and do conditional importing when needed. So this is the first part, which is managing the code base. The second part is about executing the different commands. This is where we have the build system wrapper, and where we're going to have tools to flash and debug the system. We can also do some testing, simulation, and of course we can add our custom commands. So these custom commands there might be useful to do something very custom for our projects. So I've seen a lot of projects where they have their special, let's say CMD scripts or shell scripts that's going to do some manipulation to adapt their project, or they do their own auditing or analysis for their project. So instead of each one having their own way for doing this, now we have a standard tool for doing these commands. And all of this is managed under the West workspace. And what is a West workspace? Is just a folder that has a subfolder called .west that has a configuration file that's going to give the configuration of this workspace. So that's it in simple words. It's just a tool that has two main features: managing the Git and executing the commands. So regarding the terminology here, we're going to use the concept that's called a manifest. So a manifest is just a simple file that's called west.yaml that is going to tell what are the repos that we need them, and also going to tell additional things, but this is mainly to tell what are the different repositories in my system. We also have the workspace, which is a folder that's going to where this is where I'm going to clone the different folders. So we're just going to it's like repo, the different repositories is going to be in this folder. And when we say project, and a project here is just one of these repositories that is managed by West. So this is basically a project. And the different commands, these are the operations that we need to run with West, like doing West init, West build, West flash, and so on. So let's start going more in depth about the repository management. So here we have the West manifest. So when we say manifest, it's just basically the west.yaml. And the West manifest is going to describe the different repository and projects that are used in my workspace. So I'm just going to specify from where I'm going to fetch them, and which version or tag I want to get, where I want to place them locally, and where to find them inside this workspace. And also, if I have some custom commands, where I can find these custom commands. So in simple words, it's just the manifest is just the central coordination point for a multiple repository that is embedded in your software stack. So so it may be placed in different locations. So this west.yaml, it could be placed in different locations in your workspace, and we can also have different west.yamls in the system, and this depends on the different topologies that we have in Zephyr. So actually, we have three different topologies in Zephyr. The first topology, it is called the T1 start topology. And in this topology, basically, we have one west.yaml, and this west.yaml, it is inside Zephyr. So Zephyr is the manifest repository, because on the main Zephyr code, there is a file called west.yaml, and this is the one that we're going to use. So it uses this west.yaml inside the repository, and this is the one that we're going to fetch, or we're going to parse and understand when you do west init. So when you do west init, or just west init -m, and you give the link to the official GitHub for the Zephyr repository, this is how we can get it. And it's going to read the file inside this repo. So inside this west.yaml is going to define also the other modules and the other projects in my repository. So it's going to, and by default, is not going to add your application. So your custom application is outside this topology or this setup. Okay. So it's going to have Zephyr code and all the modules pointed by the Zephyr code, by the official Zephyr one. So why you shouldn't why you should avoid this topology, the T1 topology. By the way, the T1 topology is the one that you're going to use if you follow the get started in Zephyr. This is the easiest way to get started. So if you follow the getting started in Zephyr, they will tell you just do west init and just build your application, and it's going to work. In this case, you're going to build the application that is in one of the samples. But in real life, this is not what we're going to do. In real life, we're going to have our own things, and we're not going to use any of the samples in the setup. So here, all the modules listed in the Zephyr's manifest are going to be fetched, and including all the HALs. And most of them, I don't need all the HAL. If I'm using an NXP product, why should I get the Nordic HAL? I don't need it. And believe me, the source code is just becoming, of all these HAL, is just huge. You're going to fetch like hundreds of megabytes, if not even like a couple of gigabytes, only for the different HALs that you're not going to use in any way. And this will increase the download size and also will add some confusion because you're just going to add a few things to your project that you're not going to use, and there's something wrong over there is going to break everything. This is not a good idea. And there's also no link to your own custom app or modules, and you're just locked in with the version and the structure dictated by Zephyr. So everything is just defined in Zephyr. You're just locked in by what is inside this specific Zephyr version that you've got. So in this setup, the layout, this is the standard layout. Basically, you have in the workspace, you have the .west. This is to tell that this folder is a workspace. And under Zephyr folder, you have a west.yaml, and this is the central manifest that we're using. And we have all the modules here. So here I just mentioned the HL from NXP, but you have everything, not limited to those. Like you have all the modules and maybe the bootloader. You also have other third-party, other libraries that are going to be included. And last time I checked, it was like around 7 gigabytes of, I think, 7 or 4, I forgot, but it's a lot. And you're not going to use this. So this is why we have another topology. This is what we call a T2. So this T2 topology is for application. This is where your application is going to contain the main central manifest. So what is this? It's actually your application repository is going to contain the west.yaml. And Zephyr and other modules are just going to be a dependency listed inside this west.yaml. So your app becomes the center coordination point of the workspace. But in this one, we assume that you only have one application. And from this one application, I'm going to point at Zephyr and the different modules, and maybe also custom modules in this case. And this is how we work most of the time. So why this is recommended? Because it's only going to fetch modules you are actually going to use. You're just going to list and specify what you need. And your application is just going to be part of this manifest. So you can control the version, and you can control the dependencies, and you have full control about what you need in this case. So the layout in this case would look like this. Under the workspace, here you have your application. Of course, your application, you can just call it whatever you want. And here you have, inside it, you have the west.yaml. And if you look here under your application, we have the west.yaml. And this is the central one. This is the one that I'm using first. So from this one, I'm going to do a dependency to this west.yaml. I'm just going to list what to import from this west.yaml. So I will tell, go and look at Zephyr that is here. And inside this Zephyr, do not get all the modules. Just take HAL and XP and MCU boot, and I don't need the others. I'm just going to list whatever I need. And this is how we're going to work most of the time. So the third topology, which is T3, this is the forest topology. And in this case, you just create a manifest that's going to manage multiple applications and Zephyr as well. So the central manifest, the west.yaml, is going to have its own repository. So this is typically when you have a Git repository that only has one file and a README. We have west.yaml and the README file that will tell you, OK, here we're going to import other things. So inside this west.yaml, you're just going to point at the different applications. Well, in this case, we have different applications on the same workspace. And we're just going to point at each one that is going to be on a different Git repository. So there is no single central project. All projects, the application, the Zephyr, and module are just siblings, so just going to be part of this manifest. And this is ideal for multiple applications sharing the same platform. What I mean by platform, not necessarily the same hardware, just the same environment. So in this case, the layout, I'm going to have a folder that's going to contain the west.yaml. And from this west.yaml, I'm going to point at this repo, that repo, and so on. And we can also have, so from here, I can point to the other west.yaml inside Zephyr that's also going to add the other modules and also point at the other things from different places. But this is the central one, which is not outside any of the applications. So should I use this one? You might be. You might need to use it, especially if you have the same setup but different applications. So in this case, it makes sense. If not, if you have one application, in this case, you use the T2 setup with one west.yaml in your app. So what is a West workspace? So a workspace is just a folder on your computer locally where all parts of your Zephyr projects live together. So who's going to create this West workspace? It's basically when you do West init, West is going to set up this workspace. So it's going to create this special .west folder. And the West is going to keep track. So inside it, it has a configuration file that's going to keep track about the setup in this workspace. It has a lot of things by default. So if you look at the configuration file, it's going to be pretty basic and simple. But if you start doing advanced things, this configuration file would just going to fill up with some data needed to the setup of your environment. And then from inside this workspace, it's going to clone the different repositories, Zephyr, the application, and other things. And then so it has different rounds actually. The first round is going to get the first level projects. And inside each project, if I need to get dependencies to other repositories, it's going to start the second round. It's like a recursive way to having different modules. So first place, I'm going to use my west.yaml. That's going to point at other repositories. These repositories, if they contain west.yaml, is going to get also their modules and so on. So it has a west config, which is going to have the local configuration file, and we usually do not edit it manually unless you're really sure what you're editing here. But we usually don't really need to edit it. It's just West going to manage it. We have also some special command that to help us to edit this file. So we also have projects in West. So what are projects? So projects in West is just a Git repository that is managed by West, and inside it we define the projects column. And in this section, we're just going to specify where is this repository. We usually confuse the West project with a module. So if you're familiar with modules in Zephyr, are just some folders that have a file called module.yaml. But projects, most of the projects are usually modules, but not necessarily. So just to distinct module from a project, these are distinct, even though modules are usually projects. And the simple way that you can see a project is just a repository. So in simple words, a project is just a repository that is hosted on some a Git repo. And each project has these information. So we have name, which is the unique name of the manifest. You don't need to specify any special name. You can just use whatever the name you want. You specify from where I'm going to fetch it. So we can here use remote or URL, more about them in a minute. You specify which revision and the path. So path is needed actually to know where to place it locally. So actually, you're going to have something like this. So manifest colon, the project are going to have this custom module as a project. So it could be also custom repository or that has my feature. So inside this project, I need to specify from where I need to download it. So I need the link to the Git that I have. So this is why we have two different ways. The first way is using remote. So remote is a name shortcut that is going to give you, you're going to provide a base URL of the repository. And this is useful to avoid like repeating the full URL for each and every project. And then in each project, you just give the rest of the URL, which is the repo path in the project. So example here. So when you do URL, so here in the manifest, you give the URL base is going to be this GitHub. So it is Zephyr project RTOS. But the name of the repository is going to be called here Zephyr. So the full URL is going to be this link / Zephyr. But here I provided it with a URL base. And then you must specify here remote, and you say it is actually this Zephyr project. You can call it whatever you want, but just the name should match the name that you have here. So if you have multiple projects, they share the same URL base, which is the case most of the time. You can reuse the same URL, and if you change to migrate or you migrate it to a different Git or different place, you just change the link in here, and will easily set up the rest. So this is the first method, or you can just do, you can use the URL, and URL is just the full URL, the full link. You can just directly use it. If you see it, it is simpler to use, why not? So you just give the full Git URL in the project. So this is used when the remote is not specified. You cannot mix remote with URL. So you just select one of these. And here the URL, I just provided the whole URL to the repo. We still also need to specify the revision. So to specify the revision, here it can be, the revision could be a branch, a tag, or a array. Basically here I want to get Zephyr version 4.1.0. So this is a branch or a tag in GitHub. But I can also use the revision, which is the commit array that you have. It also works.
Would that give you a range?
No. This is because the array is so long, so I just use 3 dots.
Can you abbreviate the SHA hash? Like, is it necessary to specify a rule for you?
Yeah, it is actually the commit. This is like specific in Git. When you do Git commit, it will just create a SHA-256 for this specific commit, and you just place it here. Or, yeah, in this case, you create a branch or like a tag, I mean, and you can use it.
Just in Git supports abbreviated, like when I do a Git checkout, I can abbreviate the SHA-256 on the checkout.
Oh, you mean the final part of the SHA and?
First 6 digits or whatever.
Oh, okay.
Yeah, West also supports that.
Okay, awesome. I didn't test it.
The term is commit-ish. Because the short is one.
Yeah.
Yeah, so it just has to be sufficient to be unique for that repo.
Okay.
So it just needs to be as long as ever. If you're really early on, your commit should only be like 2 characters.
Okay.
Might be enough.
I've never tried it this way.
6 or 7 would be fine for.
Well, actually, I think the good practice is actually to use the full ones. I have to know. Okay, so there's also self. Self is a bit confusing, actually. So self, this is going to control the manifest repository itself. So this is a Git. Repository and of my application. So this is your application, and inside it we have a west.yaml. So inside this west.yaml we have different things. Among the things we have self path my app. So when I do this, Zephyr is going to understand that whatever I have in this repo, I just need to just copy and clone my repo into this folder that's called my app. So all the files that I have here are just going to be copied into my app folder. So this is a nice way to restructure your application. Because in the repo, it is not nice to have a folder and say inside this folder I have the west.yaml. We typically have a repo that directly has everything. But when I want to clone it, I want to put it in a subfolder. So this is a very nice way to restructure your app inside Zephyr. So this is what self means. And if you don't want to use it, that's totally fine. You can just skip it and we'll just clone everything in the current directory. We can also use import. So import, this means that point to another west.yaml that is inside this repository. Because we said that we can have a west.yaml that's going to point to another project that also contains a west.yaml. So when you use import, it means, so here I'm saying that for this Zephyr, import the other west.yaml. So just a reminder, I already have west. The central one is inside my application. But I also want to import whatever I have in this west.yaml. So it will import everything that it will start importing the thing listed in this west.yaml. I can add a prefix. So let's say I added a folder called dependencies. So it will add a subfolder for whatever is going to import and place it in this subfolder. This is nice also to restructure your app. And at the end, I can just do an allow list, which basically means that do not get everything because, for example, HAL Nordics, I don't want it. I'm using an XP board. I don't want to get the other from other vendors, and I don't want the other modules. So you just specify an allow list to get whatever you want. So here you have also a couple of other configurations. You can do also block list instead of allow list and many other tweaking. But the most common one is just allow list, and you just list whatever you want here. So this is what import means. And it is very useful for this purpose. So the layout that you find here, so under modules, you have debug, and under debug, you have Percepio, under HAL, we have NXP, and so on. So this layout is not managed by my west.yaml because it is already managed by the other west.yaml. So all this layout is defined under zephyrwest.yaml, the one that I have imported. The only thing that I can do, I just tell that whatever I imported here, just put it in this subfolder using repo path. Very nice way to organize your project. So all of these things, we cannot use them with Git submodules or repo, or like it's going to be a bit complicated to do all of this with other tools. So this is why West exists. So if you want to get a final manifest for a T2 layout, it would look like this. This is just for reference. So here in this one, I have the first project is going to be the Zephyr project that also has the different modules. The second project is going to be my module or my library that's going to contain my custom features. And the self, my app, so this is the code for my application that has, similar to the previous example, what has my own source code. So this is the first part, and this is the first topic about West repository. So I will pass also on the different commands that we have on Zephyr. So Zephyr also provides many commands. So the commands, so firstly, West is written in Python. So commands in West are just Python functions. So you just create a Python function, and that's it. So a West command just run a script that's called West command. And you just need to specify where is this command and what is the name of this command. You just create a file called westcommands.yaml that has some special format just to tell where are these commands, where to find this file actually. And West is going to load this command from your built-in manifest. So inside your manifest, you just specify where I can find them. Or if you have a dependency and like a module, and this module also has a West command, you can also going to point at these. So built-in commands, so we have like for init, update, we can list the different projects that we have and many other things. So these are like built-in commands even without Zephyr. So these are available immediately after installing West. You can, if you want to use West without Zephyr, this is what you get. And once you install Zephyr, inside Zephyr, it's going to, when you install Zephyr, it's going to extend these commands with this specific Zephyr version that has its own specific commands, like building, debugging, flashing, and so on. You can also extend it with your custom command. So because it is pluggable, you just create a west.yaml that's going to map the different command to the different Python files. So for example, if a vendor is going to add a special flashing tool, well, this is really the case, but why not? Or a project can, if has a special way for testing, or if you want to add some command to audit your code in a special way, you can also use this command. And this will turn your West into a single or a uniform setup for a single command line interface for all the project tooling in your system without fragmenting your workflow. And in this case, you don't need to create some shell scripts or bash script or whatever they set up. Here you have West that has custom command that works on Python, which means that work on any platform. So how to do it? Just really quickly, you just create a file, a Python script that's going to have, you're going to import West commands. You can get the argument, and in this one, it's just going to print hello world. Then you must add the westcommand.yaml. Basically here, I just specify where I can retrieve this Python script. And the name of the command here is called hello, and the help if needed. And my west.yaml, I should tell where is this westcommand.yaml. And now if I do west hello, you're just going to say, it's going to give you hello from my custom West command. As simple as this. Of course, we can extend it to run CMake functions or to do some advanced commands. So Zephyr also, Zephyr itself is going to extend it with its own custom command. And this is where you're going to get the command that are needed for building, flashing, and running the testing, and so on. And all of these commands are based on the West command that you can find it under Zephyr scripts westcommand.yaml. So I'm just going to pass quickly on some other commands that we have. Just nice to know that they exist in West. So we have west build-t menu config. And in this one, just going to open the menu config needed to reconfigure or doing the kconfig setup of your system. We can also have an equivalent for GUI config, which is the same thing, but with mouse support. You can just click on the options instead of using the keyboard. By the way, what's happening here behind the scenes, just running some CMake functions. And if you really want to see which exact thing that's running behind the scene, you can just do here -- dry run, and it will show you what CMake or whatever command that's happening behind the scene. It is really nice to understand what is the magic behind the different commands. So another nice command that we have, it is harden config. So west build -t harden config. Basically, it will just tell you the different kconfig options that you have. This is recommended, not recommended. So for example, if you key the boot banner, I don't think this would be a good idea. And also some other things that we do that are not recommended. This is based on something that are part of the Zephyr code. You can also add your custom one. So if you want to add your custom auditing of the kconfig here. You can also do some reports. So for example, we can do a RAM report, and this will show you the different variables where they are going to be placed in the RAM, the BSS data sections. We can also do a ROM report. This will tell you where these different variables are going to be placed in the memory and different which section as well. And here on the flash or ROM. We can also use pun cover. I really like this tool. This tool is going to give you a static to get stack analysis at build time. This is really powerful. It will just open a tab, browser tab, and will show you here the worst case scenario of the stack. So here I have a function called LED entry, let's say, and it's going to call the different function and will give you the worst case scenario for the stack. So in this case, it's going to be 2080 bytes. So it will give you an idea how much you're going to reserve for your stack. Other notable West command would be nice to mention here. We can sign the firmware when you have secure boot. You can have West blobs to download some precompiled binaries. We have SPDX. This is needed to generate the software bill of material. And now with the CRA coming, this would be also something to take into account seriously. And if you're using LLX, which is a very interesting framework, highly recommend, if you're not familiar with this one, just to also visit the documentation to see how it works. It will allow us to create some extension for the already available application. And also sysbuild that will allow us to create a multiple application in one build at the same time. This is really also nice to have. I would also like to add here, I did not mention a lot of advanced things that we can do in West, like doing aliases or doing also a few operations that we can run on the different modules, and many other advanced things that we can do. Here's just the purpose, just to show you the most common features in West that will cover most of the common use cases of West. I would also like to mention really quickly that we have also the Zephyr Workbench extension. This is an open source extension that is basically a West West executor. It's just going to be extension. So when you run, for example, on this project and this application, when you do right-click configure menu config, it's just going to call the West build -t menu config and open it in the VS Code. So you don't need to manually run these different commands. And you can also structure and manage your application within VS Code. So without using the command line, everything can be managed directly here. And if you still want to use the command line for some operation, you can open a terminal within the West interface for this specific application and run whatever the operation that you'd like. So thank you very much. And I hope you enjoyed this quick presentation about West and how it works in simple words. Thanks. Yes, please.
The dry run type you were mentioning, does that apply for any West command? Can you run dry run for any West command?
No. It only works, I think, with build. I've never managed to make it work with different commands.
Okay. And then the second question, sysbuild, is that like for building a bootloader plus application, or is it for building multiple applications with like different cores, or?
So typically, when you want to build like a bootloader and your application, so there are like two different binaries with the same application. So this is where sysbuild is going to be handy.
Okay.
So this is the most common use case actually. Sometimes we also use it if we have two different cores. it is asymmetric module, so you have two applications on different cores. This is where we can also use this split. Thank you. Yes?
Does Zephyr maintain West, or is that West maintained by the separate organization?
Yeah. So the question is if Zephyr project maintaining West, or it is like a general project. Actually, Zephyr West is started with Zephyr, and it's still managed by the Zephyr project. Everything with Zephyr project. But I totally see like West a project by itself because it is becoming the standard for the build system actually. Thank you. Sorry. Yes.
As a feature request, can West build learn how to not need me to do a West Zephyr export first?
Actually, I don't like the Zephyr West export actually. Yeah, so you can just actually not use it.
I mean, if I don't use it, then builds don't work because
Why?
I can't find the CMake module that gets installed into my home directory.
But you can still specify the Zephyr base and it would work. You just point it with the environment variable. I think you need Zephyr base and the SDK install directory. And I think only Zephyr base will make it work. Have you tried it with creating the Zephyr base variable and just point to the Zephyr directory? Yeah, and I don't usually use this, the export. I don't like anything global, actually.
But if like the West workspace already knows this information, why would I need to provide it?
I'm not sure, to be honest. I think if you build it directly from the app, you don't need, I'm not sure, to be honest. I don't know. But for the tool chain, you don't need to do the setup. You can just point it forward with the variable. So you can avoid doing the Zephyr SDK. Without doing the setup, you can replace it with a Zephyr SDK install directory and give the path to your Zephyr SDK. And in this case, if you change to a different version or you need to use different version, you can easily switch. Yeah. This is the way I use it, actually. Yes. Yes, please.
In the T3 repository configuration, what directory are you executing West from, I guess?
Oh, so you still need to build from the different application.
Yeah.
But the purpose of having this manifest just to structure and to know from where to fetch your application, because your application is the application 1 is going to be on repository A, and application 2 repository B. So just only for fetching, but still building, you just go to build with the different apps. So you do West build app A, app B, and so on.
Okay, and app A and app B dependencies would point to their pure directories, basically, to point to like Zephyr SDK.
Yeah, just the workspace where you're pointing from. So your West build is going to understand this workspace. It has these different modules, and I want to build the app A.
Yeah. Okay.
Yeah. Other questions? Yeah. Thank you very much. And yeah, thanks.